6.1b, slope fields and differentials. I need a reader up in her, and let's go, TJ. Go for it.
Recall that a differential equation in x and y is an equation that involves x, y, and derivatives of y. A function y equals f of x is called a solution of a differential equation. If the equation is satisfied when y and its derivatives are replaced by f of x, and its derivatives.
Keep going.
The order of a differential equation is the order of the highest derivative involved in this equation.
All right, good job. So I want to talk about this called this order of the differential. So if we have like y double prime plus y is equal to y prime, that would be a differential equation because it has derivatives and your other variables. All right, so that's what makes it a differential. But I want to talk nerdy real quick. What order is that differential equation? What order is that?
Second.
It's a second. It's an order of 2. All right. So if I had y triple plus y prime is equal to y double, what would be the order of that differential? Third. All right. That would be a third order. All right. Let's keep moving. So I have to determine whether this function is a solution to this differential y double prime minus y is equal to 0. And the first thing I'm asked is to see if y equals sine x is a solution to that differential. So the first one I try to check is y equals sine x. Well, what do I need to get to, though? I need to get to the second derivative. So let's take a first derivative. So y prime is equal to what? Cosine x. And then y double prime would be equal to negative sine x. So I have, what's my y double? Negative sine x minus, what's my y? Minus sine x is equal to 0. So negative sine x minus sine x is what? Negative 2 sine x. Are those the same? Does that work? No. No. So this is not a solution. All right, that is not a solution to this differential. All right, let's keep moving. So now I need to test if y equals 4e to the negative x is a solution to that differential. So let's do y prime. So what is y prime? Negative 4e to the negative x. But I need to get to what? Y double prime. So y double prime would equal what? 4e to the negative x. So now I'm substituting that in for my y double. So now I have 4e to the negative x minus, what's my y? 4e to the negative x is equal to 0. So 0 equals 0. So what do we know? This is a solution. All right. Pretty good? All right, let's look at part C. So y equals ce to the x. All right, it's just a constant multiple. He's going to be fine. All right, so now what's y prime? C to the x. What's y double prime? C to the x. All right, so now I just substitute in. So now I end up having ce to the x minus ce to the x is equal to 0. So is it a solution? Yes, that is a solution to the differential. So if I give you a multiple choice problem on the test and I give you a differential somewhat similar to that, not exactly like that, but something similar to that, and I give you some answer choices, you think you could pick the one that's the correct solution?
Yes.
All right, cool. All right, let's do this one now. Gunner's going to read for us.
I had a question on the last one. For the differential equation, x y prime minus 3y equals 0, verify that y equals c to the x to the third is a solution, and find the particular solution determined by the initial condition y equals 2 when x equals negative 3.
All right, fantastic. So this is a two-part question. All right, the first thing we need to do is verify that y equals cx cubed is a solution to the differential x y prime minus 3y is equal to 0. So that's what we're going to do first. Now, what's the order of that differential? First. All right. So now, what do we need to get to? A first derivative. Well, y prime would equal what? 3c x squared. It's just the power rule. So we bring down 3, subtract 1. So now we're going to substitute in. So now I end up having x times, what's my y prime? 3cx squared. Minus 3 times, what's my y? cx cubed is equal to 0.
Whoa.
Well, what happens?
It works.
X times x squared is?
X cubed.
So now I have 3cx cubed minus
3cx.
3cx cubed is equal to 0. Does it work?
Yeah.
Yes. Now, we already knew that it was going to work. Why did we already know that it was going to work?
Verify.
It says verify. All right. So they don't do this often, but they can, and they have before in College Board. If they ask you to verify, you already know the answer is going to be yes, it works. Okay, what are they looking for then? They're looking for this work. Does that make sense? Okay, they do that sometimes. I'm not going to say completely often, but they do it sometimes. All right, now we need to find the particular solution given with this initial condition. Now, I personally don't like the way they gave that initial condition. I'm going to make it into an ordered pair. So what would be my ordered pair?
Negative 3, 2.
Negative 3, 2. All right. Now, they give me this y equals thing already. So they did the hard work for me. So y equals cx cubed. So what do we need to solve for?
C.
We need to solve for c. So now what's my y? 2. So now I have 2 is equal to c times what's my x? Negative 3, and I'm going to do what to it? I'm going to cube it. So negative 3 cubed is? Negative 27. We divide. We end up getting c equals?
Negative
2 over 27. Now, what do we do after we get c? Substitute it back in. So now we get y is equal to? Negative 2 over 27x cubed. And that is my particular solution. Pretty good?
Yeah.
All right. So here we go. We're going to match the slope fields very similar to what Ansley did on 13 through 16. All right, so the first thing I have is y prime is equal to x plus y. So how do I want you to think of going through these? Set dy dx equal to 0. So when I set dy dx equal to 0 on that first one, I'd get what? X equals, or y equals what? Negative x. Well, which one tells me y equals negative x has 0 slopes? B. All right, I have 0 slopes going on the line y equals negative x. All right, so that one is B. All right, this next one, I have y prime is equal to x. So dy dx is equal to 0 when what? X equals 0. And when does that happen? A. X equals 0 is another name for what? The y-axis. So that is A. All right, let's look at this next one. dy dx is equal to 0 when what? Y equals 0. And that happens at C. All right, that would be my y equals 0. Now, I want to do another quick one. If I asked you to draw a solution curve to, let's look at B. Let's say I have the initial condition of 1, 1. 1, 1 would start right there. Yes? Now, if I were to draw a solution curve, it kind of goes with the flow. That's the way I kind of think about teaching this. So, if I go to the right, which way would I be going? I'd be going up. Be going kind of like that. True? And then if I were to be going left, which way would it be going? Down, and then what? And then it starts flattening, and then what? It starts kind of going up. Something similar to that. Pretty good? You guys can handle that?
Yes.
Okay. All right. I'd like you to write those down, and then we're going to do a couple more together. Oh, hold on. I think I gave you the wrong. Yeah, skip 3. Yep, skip 3 and 9.
Skip
3 and 9, I'm sorry. Elijah's going to read what we're doing for number 4.
Y squared minus, oh, you mean the actual?
Yes, the directions.
In exercise 1 to 8, verify the solution of the differential.
Yeah!
So we're just going to verify that this is a differential. All right. Now, on before on our notes, we had like y double prime minus y is equal to 0, right? Do we have that in this case? No, we do have a differential because we have dy dx is equal to things with x's and y's, right? So it's still a differential. However, we're going to go another way to Tampa, and that's why I want to go over this problem. So what could we do to this left side, the original problem?
Derive it.
We can derive it. Exactly. That's what we're going to do. So let's do it. So the derivative of y squared is
2y dy dx.
minus the derivative of 2 natural log y is 2 over y dy dx is equal to 2x. All right. And so what are we going to divide by? So dy dx is equal to what? 2x over 2y minus 2 over y. Exactly. Now, we still have a complex fraction going on. So what are we going to multiply by? Y over y. So now in my numerator, I have 2xy over 2y squared minus 2. Now, does it look the same yet? No. What do we need to get rid of? Just a 2. Divide everything by 2. So now I have xy over y squared minus 1. All right, pretty good?
Yeah.
All right. Look at number 2. Look at number 2 just with me real quick. So on number 2, we have y equals e to the negative 2x. And then it gives me a differential of 3y prime plus 5y equals negative e to the negative 2x. So that's how we did it on the very beginning of our notes. Remember? And so we solved for y prime, and then we substituted in that differential. See if it works. It will. Okay? Pretty good? All right. All right, let's look at number 10 now. Let's look at number 10. I'm going to read what we're doing in number 10.
In exercises 9 to 12, verify the particular solution of the differential equation.
All right. So we need to verify the particular solution. I want to actually verify the differential as well. So again, very similar to number 4 in which we just did. Let's take a derivative of that. So y prime would equal what? Derivative of 1/2 x squared is just x. And then the derivative of negative 2 cosine is positive 2 sine. The derivative of negative 3 is 0, so that goes away. Are they the samesies?
Yep.
Yes. Then it says verify the solution to that. All right, so all we're going to do is we're going to substitute in. So now we'd have negative 5 is equal to 1/2 times 0 squared minus 2 times cosine of 0 minus 3. Well, 0 squared is what? 0, so that goes away. Negative 2 cosine of 0. What's cosine of 0? 1. So now I have negative 2 minus 3. Is that equal to negative 5? Yes, it sure does work. And that's all we're doing on that problem.